Hi, this is Miss Parley, and this is your flip video for 6.3 special right triangles. The two types of special right triangles are 45-45-90 and 30-60-90. These are some rules and formulas that you're probably going to want to memorize just because they're like shortcuts. So if you want to pause the video and write down what's on these slides behind me, that would be a good idea. It's also going to be on your right-hand side when you get these on Monday. All right, so the way that we create a 45-45-90 triangle is by taking a square and drawing in the diagonal. So basically, if you make the sides of the square 1, because that's like the smallest, easiest number to work with, our goal is to figure out what the hypotenuse will be. Now, this is a common ratio for all squares because all squares, your legs of this right triangle would have to be the same because the square, all sides are equal. All right, so if we use the Pythagorean theorem, we get that the hypotenuse is always going to be the square root of 2. It's always going to be the square root of 2 times whatever your legs are equal to. So these are the rules for how to find the missing sides of 45-45-90. If you're looking for the missing legs, you need to take the hypotenuse and divide it by the square root of 2. And if your goal is to find the hypotenuse, you need to take the legs and multiply them by the square root of 2. All right, so let's do some examples. All right, in example number 1, let me see if I can move this closer. In example number 1, you see that the hypotenuse is 12 square root of 2. Well, if you look back to what the rules were, the hypotenuse is always going to be radical 2 times whatever your legs were. So basically, I just need to take this and divide it by the square root of 2. Once you do that, those root 2's are just going to cancel, and your sides are 12. So it would be 12, 12, 12 square root of 2. That follows the rule. That's what it's supposed to look like. All right, if you look at number 2, I'm given that the legs are both 8. So if you need to find the hypotenuse, we need to just multiply by the square root of 2. So it would be 8, 8, 8 root 2. All right, now if you look at number 3, I have the hypotenuse. So my goal is to find the legs. Now this is the same way that we did number 1. We're going to have to do this. The only difference is this root 2 canceled out nicely. If you look at number 3, this 10 does not have a root 2. But we still need to divide by root 2. Because whatever my legs were, I had to multiply those legs by root 2 in order to get 10. So 10 divided by root 2. We're not going to have any decimals in these. What we need to do here is rationalize the denominator. The way that you rationalize the denominator is you multiply both by radical 2. So I need to multiply the top and the bottom, the numerator and the denominator, by root 2. All right, now root 2 times root 2, this is just going to give me the square root of 4. Well, the square root of 4 is 2. That's pretty much the whole purpose behind doing this step is so that we get a whole number in the denominator. So on top, my numerator, I'm just going to have to leave 10 root 2. I can't really do anything else with that. But now it's 10 root 2 over 2. Well, I can simplify this further because I can do 10 divided by 2 and get 5. And then I would just have to drop down the root 2. So my legs are actually both 5 root 2. This is the correct way to do this, and we don't want any decimals. You could use SOHCAHTOA for these, but SOHCAHTOA is going to give you decimals. We need to get used to what these rules are because they're going to help us create the unit circle, and the unit circle is going to help us understand the graphs of trig functions, whereas that's the direction that we need to go. All right, so again, if you have the legs, you need to multiply by root 2. If you have the hypotenuse, you need to divide by root 2 and rationalize the denominator if it doesn't cancel. All right, let's move on to the other kind of special right triangle, the 30-60-90, which we're going to create using an equilateral triangle. So an equilateral triangle starts off with all of the angles are 60, but I'm going to draw the altitude, which will split it in half. So it's actually going to make these two up here both 30. All right, so we didn't want to start with 1 because we just split it in half. So we're going to make the shortest piece equal to 1. And since it was equilateral, that meant that all of the sides actually started out as 2. So my hypotenuse is still one whole piece, so that's 2. All right, so same thing, we're going to use Pythagorean theorem to figure out what the other missing side is. And if you work it out, you get that it would be the square root of 3. So if you notice the relationship between these sides, the short leg is 1, the hypotenuse is double, and the other leg will always be this times root 3. So I kind of remember as 1, 2, square root of 3. Hypotenuse always has to be bigger. You can check in the calculator, root 3 is like 1 point something. All right, so here are your rules for finding the missing sides. If your goal is to find the longer leg, you're going to take the short leg and times it by root 3. If your goal is to find the short leg, you would take the hypotenuse and divide it by 2, or you would take the long leg and divide it by root 3. And if your goal is to find the hypotenuse, you would take the short leg and multiply it by 2. For this, it's always easiest if you're trying to find all the pieces if you know what the short leg is. So that's why you don't see it go from the long leg to the hypotenuse, because that's kind of a two-step process. All right, so here are some examples. Now, most of these are probably going to be drawn to scale, but if you remember the hinge theorem about opening the door wider or keeping it closed a little bit smaller, wherever your 60-degree angle is, whatever side is opposite is always your longer leg. So they gave me that this is 60, so I know that this is my long leg, this is my short leg, and there's my hypotenuse. So I have the short leg. I know that my hypotenuse is always double, so my hypotenuse would be 8. And your longer leg is always whatever your short leg is times the square root of 3. So that's it. 4, 8, 4 root 3. All right, if you look at number 2, they gave me the hypotenuse. The glare is kind of right there, but that says 30 degrees. So if that angle is 30, I know that this is my short leg, and there's my long leg. So my short leg is always half of the hypotenuse, so 18 divided by 2 is 9. So that means that this side has to be 9. And then my long leg is always the short leg times root 3. So it's 9 root 3, 18. All right, now if you look at number 3, here's my 60-degree angle, which means this is my long leg. That makes this my short leg, and then of course my hypotenuse. Well, my long leg is equal to 12. So again, this is kind of like the last example on the other side. This number means there was something here that I times it by root 3, and I got 12 as my answer. So we have to work backwards. We're going to have to take the number 12 and divide it by root 3. All right, again, I don't have a root 3 up top that I could just cancel that out, so I'm going to have to rationalize the denominator. So we need to multiply the numerator and the denominator by root 3, so that'll cancel. So this will give me root 9. And root 9 is equal to 3. That's my goal. On the numerator, I have 12 root 3. And now that's being divided by 3. So I can do 12 divided by 3. That I can simplify to get 4. So that means that my short leg is 4 root 3. All right, the root 3 would just have to drop down. All right, so now I can find my hypotenuse. All I have to do is double it. So 4 root 3 times 2 is just going to be 8 root 3. All right, so those are your rules for 30, 60, 90. You have to take the short leg and times it by 2 to get the hypotenuse, and times it by root 3 to get the long leg. And if you need to work backwards, you're always going to do the hypotenuse divided by 2 or the long leg divided by root 3 to get your short leg. All right, if you need to rewind this and write any of those rules down, there's also a PowerPoint on Edmodo that goes through pretty much the same thing. So hopefully you'll have watched that before tomorrow.